didn't write it right. 6.43 over 2.34, shift tangent. Apparently I did write it right. Okay. So this is the way to solve it. This is why we are going to solve it in problems. But I want to show you another way, because you may see also other ways. To add vector or to find the resultant, you can do the following thing. You can take the vector 10. Remember, as long as I maintain the length and the direction, it's the same vector. And what adding vector in maths is to put the other vector. I want to add this into that to that, or to add this to that. It doesn't matter which one to add to. Let's say I put this one first. Then what I do is I take this vector, the 10, and add its tail to this one's head. At exactly the same angle, 40 degrees. So I take the first vector and I add to its head the tail of the other one without twisting it, maintaining the same magnitude, the same direction. If I connect the tail of the first vector to the head of the second vector, this will be the resultant. And this will be the direction. You can see intuitively that it's exactly the same, looks exactly the same. Let's calculate it. Now, how do I calculate it? Here, because it's a symmetrical problem, it's an isosceles. You can do other things, but if it was not a symmetrical problem, you use the cosine law. The cosine law says that f squared equals to 10 squared plus 10 squared minus 2 times 10 times 10 times cosine 40. If you don't know the cosine law, forget about it. If you know, you understand what I'm talking about. So f will be 10 squared plus 10 squared minus 2.10.10 cosine 40 and square root 6.84. Exactly the same. Now, if I want the angle, I should use the sine law, but here I don't even have to use it because it's a symmetrical problem. If this is 40 and this is an isosceles, you can see 10 and 10, this alpha and this is also alpha because they're both the same. So alpha and 40 must be 180, so alpha should be 70 degrees. So this is the way, another way to find the resultant force. Not breaking into components, but doing something different. Let's do another one, which is not symmetrical, so you can see the whole picture. So, think 9. Okay, something which is not symmetrical. Let's put, this is 10, 45. Well, this is symmetric, but this one will not be. Let's do that one, which is 15. Definitely not a symmetrical question. The ball will go somewhere here or there, somewhere like this direction. I want to do it. I want to find it. Again, let's do it both ways. First way, like we did up until now. We break it into the components. This will be 10 cosine 45, and we already know that it will be exactly the same, or 10 sine 45 or 10 cosine 45, because this specifically is symmetrical to the axis. So 10, let's write again, cosine 45. I'll take the calculator, 10 cosine 45, 707, 707, and let's draw it again. I have 15 here, 7 there. The 15 will win. By how much? 15 minus 7.07, it's 7.93. Here will be 7.07 because nothing pulls it up. And the resultant will be here somewhere f, alpha always with the x. F will be square root of 7.93 squared plus 7.07 squared, which is squared plus 7.07 squared, square root, about 10.62, okay. Tangent alpha, always y over x, 707 over 7.07 over 7.93, shift tangent, 41.72 approximately. So we already know how to do it. Let's do the another way. Okay, the other way, I choose one vector, it doesn't matter which one. Let's choose this one, okay? I take the 15, this is 15, and I want to add to it the 10. So how do I do it? I take the 10, I take its tail and put it to this one's head at the angle and maintain the 45 degrees, like that. This is 10, this is 45 degrees. The resultant vector will always be from the tail of the first to the head of the last, this one. And the angle, if I want let's say this is f, and the angle will be, I want this angle. It's exactly the same as this one. You can see that it looks as if it will be in the same direction. It should be the same. Let's calculate it. Again, to find f, I can't use trigonometry with the right triangle because this is not a right triangle. I have to use the cosine law. Cosine law is f squared equals to 15 squared plus 10 squared minus 2.10.15 cosine 45. This is the cosine law. It's not a mathematical teaching now, so if you don't know it, leave it. If you know it, you know another way to do these problems. 15 squared plus 10 squared minus 2.10.15 cosine 45 square root 10.62, exactly the same. Now to find the alpha, I need the sine law. The sine law says every triangle, if I take the 10 and divide it by sine alpha, 10 over the sine angle opposite it will be exactly the same as if I take another side, say the f, I have it, it's 10.62 over the sine angle opposite it, 45. This is the sine law. It says side divided by the sine of the opposite angle equals to not this side or this side, doesn't matter, we choose this one, this side divided by sine of this angle. So if I solve this one, I'll multiply it, so it's 10 sine 45 equals to 10.62 sine alpha. Let's go here. Sine alpha will be, I divide it by 10, so it will be 10 sine 45 over 10.62. And if I want the angle, the alpha, I do shift sine, and I write all this. 10 sine 45 over 10.62. It comes to 41.7, exactly the same. 745, this is 72 because I round up a little bit here, but it's the same idea. 7, let's remain 7. Okay, so this is another way to find the resultant force, a more advanced way. Last exercise, and for now, after that, we can say we know how to break forces or vectors into their components and how to add them back into one resultant vector. Last example, 10. Let's do it also both ways. Let's do, I'm out of ideas now. Okay, let's do okay, let's say this is 30 p squared over t. I don't know what it means, but I just write it with 45 degrees. And let's do this one, which is 20 p squared over t with the angle of 20. And I want to find the resultant force. So this is our summary. Let's do two different ways. One way, like we all should know, breaking into the components. I remind you, leave these two, don't use them. Use only the coefficients, the numbers, and then in the end, we just add this, whatever I wrote here. So when I break it, I get, let's do in the calculator. 30, this one will get the cosine. 30 cosine 45 is 21.213 to 1. This one will be exactly the same, we talked about it. Okay, let's break this one into these two components. So this one will be 20 cosine 20. It is 18.79. And this one will be 20 sine 20. It is 6.84. Okay. Again. Okay. So here the 21 wins the 6, so it's 21.21 minus 6.84. It's 14.37. Again, 21 overcomes the 18, so it's 21.21 minus 18.79 is 2.42. I want to show you another thing. You see, this is 14, this is 2. So if I were to draw it proportionately, it should be much longer. It should be 14 point... I forgot how much I wrote. It was 21.21 minus 6.84. 21.21 minus 6.84, 14.37? I don't remember this number. And 2.42. Again, 21.21 minus 6.84. Okay. Anyway, this is much longer. So what I expect is that the resultant will be something like that. So the angle I'm looking for must be more than 45 degrees, because 45 is exactly in the middle. It must be more because this is much stronger than that one. The ball should go more high, more to this direction than to this direction. Something to think about. So the F will be square root of 2.42 squared plus 14.37 squared is equal to 2.42 squared plus 14.37 squared, square root 14.57, and tangent alpha will be always the y, 14.37 over 2.42. Let's see if it's more than 45 degrees. So it's 14.37 divided by 2.42, shift tangent, much more, 80.44 degrees. So this force, the resultant force, is instead of these two. Second way to do it. Again, if you don't understand it too much, not to worry, you will not use it too much. But if you want to learn advanced physics later on, you should do it. You should know it. Okay, we take one vector, it doesn't matter which one. Just one thing I forgot. The result, you should add there this letters, p squared over t. When you want to finish the exercise, just put the coefficient, the number that you find, add these letters to it, okay? Okay, the second way, let's take one vector, it doesn't matter which one. Let's take this one. it's 30, and here is 45. And we add to its head the tail of this one. The tail of this one is, let's do a little bigger drawing because we won't see anything. Okay, this is, we said this is 30 and in 45 degrees. And to its tail, we take this, to its head, we take this vector and put it here. It's 20, and the angle is 20, this is 20 degrees. Okay? If I were to copy the horizon, the vertical x, so the 20 is here. Okay, so I take the first vector, and to its head I put the tail of the other vector. I don't change the direction, I don't change the magnitude, I just move it. The resultant vector will be always from here to there. Let's call it f, and the angle, I can find this angle, I can find that one if I draw a y, x, let's say alpha, I want alpha, and when I find alpha, when I finish the problem, I will say that the angle is alpha plus 45 because I want to show the angle by the x side. This is x, so this alpha plus 45. Again, it's not the right triangle. I can't use sine, cos and tangent like we used to. We need the cosine law. The cosine law says f squared equals to 20 squared plus 30 squared minus 2.20.30 cosine. Okay, one more thing. If this is 45, this one is also 45. Why? Because these angles are, how do you call them? These angles are the same. They are called interior alternate angles, I think. Because my English is not perfect. I'll just make sure. Alternate interior angles. Alternate interior angles. Okay. Because these two are parallels, these are interior alternate angles which are the same. So if this is 45, this is 20, this will be 25. And now I can use it for the cosine law. F squared equals 20 squared plus 30 squared minus 2 point that point cosine 25. So F will be, I go to the calculator, 20 squared plus 30 squared minus 2.20 times 30 times cosine 25 square root 14.575, exactly the same. And if I want the alpha, let's do the sine law. 20 over sine alpha, side over this sine of this angle, equals to 14.57 over the angle opposite it, which is sine 25. So if I want the sine alpha will be, multiply that and that, division, it will be 20 sine 25 over 14.57. I go to the calculator, 20 sine 25 over 14.57, shift sine 35.46. But if I want to show the vector we said this is f, and I usually want to show the alpha next to the x pole. So it will be alpha plus 45. Alpha is 35.46 plus 45. It will be 80.46. And f was 14.57. Don't forget to add p squared over t because I just invented it up. Why is the slight difference? Because I round up a little bit in the middle. So, but it doesn't really matter. Okay, So that concludes our adding vectors. We saw many ways, symmetrical ways, head to tail ways, but the main way that you should know is breaking the components, adding the x, adding the y, and then using these formulas. Now we concluded our introduction to physics, the mathematical tools, vectors, and the next lessons will start physics, forces, Newton laws, etc. Thank you.